High availability is the ability of a system to remain operational with minimal or absolutely no downtime. There are many standard practices which are followed industry-wise to achieve high availability: redundancy, automatic failover, database splitting, load balancing, multi-zone architecture, multi-region architecture, data replication, etc. are some of them. In today's lecture, we will be going over them one by one and see how this can help to improve the overall availability of our service. The very first thing which helps us to achieve like high availability is the redundancy. Actually, redundancy is the fundamental concept of achieving high availability, I would say. So you can have like multiple components of one service. If one component fails or goes down, another can take over. Let's think about this scenario where we have a customer is calling our web server, then web server is communicating to our app server, and the app server is talking to our DB server. So now we have a opportunity of single point of fail everywhere, right? If one of the servers goes down, our service won't work. How can we overcome this? We can introduce redundancy. Say for example, rather than one instance of our app server or DB server, we can keep or maintain 3 different instances. We can do the same thing for our web server, but here I am just showing only 2 of them. So this is one way. If one app server goes down or the DB server fails, the other 2 will still work and can serve all of our traffics. So this is the concept of redundancy, and it is the basic or fundamental concept for achieving high availability. The second mechanism is load balancing. Say we have multiple kind of like instances of our servers, right? We need to make sure like one server is not becoming overwhelmed and failing at some point. So we need to make sure that. That's why we need to build up a mechanism which can balance the load between our servers, right? Or among our servers. That's why we can introduce a load balancer in front of our app server and DB server where we have multiple instances. Now, the load balancer itself can become a single point of failure, right? That's why we can introduce like backup load balancer. If the primary load balancer fails, secondary or the backup load balancer will take over. Number third, automatic failover with fault detection. In case of a hardware or software failure, our system should have the mechanism so that it can just detect it itself and use the backup components without any manual intervention. Number 4, service and database splitting. For services and databases, we should always try to come out of the concept monolithic architecture, right? Say for example, we have one big giant database where we have all the data like for user, friends, and newsfeed functionalities. Or if for some reason that database is not working, then all of our business parts will fail functioning, right? But if we can like distribute them all the functionalities and database for user in a separate server or separate database, for friends, for newsfeed separately, then for some reason if one database does not work, the other 2 business entities still can work properly. So that is the concept here. Number 5, data replication. Critical data is duplicated and synchronized across multiple locations, ensuring that data remains available even if one location experiences a failure. Number 6, multi-zone architecture. This is one of the important architectural thing for achieving high availability. Say for example, we have multiple instances of our app server and data server running, right? But they are all in one single data center. What will happen? If the whole data center goes down, our service won't work, no matter how many instances we maintain. That's why AWS and other big cloud service providers kind of introduced the concept of availability zone within a region. Say in US East 1, we have 3 different availability zones, What does this mean? These availability zones are kind of completely independent from one another, and they are connected with like mm, optical fiber cables, which maintains the very low latency and communicate and make sure data are sync in between uh, the regions or among the regions. Now, if we only deploy all of our app server and DB server in one availability zone, if that goes down, our whole service will go down. Rather than, what we can do, if we are launching 3 different instances or like 6 instances of our servers, we can distribute them among data centers. This way, even if one data center totally goes down, other two will be still there and we can serve our customers. That is the concept of like multi-zone architecture. Now, what if the whole region, we have 3 different availability zones, that means 3 different independent data centers, but the whole region went down. So what will happen? To recover from this kind of scenario, when the natural disaster will hit us, we can implement the concept of multi-region architecture. And these regions are kind of like totally independent and located far away from one from another. And right now AWS has kind of almost 30 regions throughout the world, and we can maintain our services in multiple regions if one region goes down, so that others can still work and serve our business, right? Now we have something we can do within our like implementation details to make sure our service is highly available to our customers. Say for example, eliminate the scalability bottlenecks. We need to identify system components that can go beyond the resource limit of a single VM or single zone. If we find something like this, we need to redesign our services so that we can scale horizontally, because this will give us like the higher chance of availability. But if we just go or grow vertically, everything in one single places or single VM, we still have the risk of failure. We don't want to do that. Number 9, tolerate overload. Our system should have the mechanism to detect overload and return lower quality responses, or like drop some traffic like partial traffic, rather than completely fail under overload. Number 10, mitigate a spike. A spike is pretty common, right? If we have a service like a streaming service, when we are having some kind of like popular game, we will see some spike. Amazon sees a spike in their Prime Day and other events. So our system should have the mechanism to identify the spike and mitigate itself. And for this, we can do some kind of things on our server side like throttling, queuing, load shedding, and prioritizing like critical requests. Number 11, validate input. So erroneous or like malicious inputs can cause like service outages or like security breaches. That's why we need to sanitize and validate input parameters to make sure it does not stop our services. Number 12, implement retry mechanism. So we might be calling like other 3 or 4 different services, and we can experience failure. We should retry the transient or like recoverable failures rather than just failing at the first time. Also at the same time, our service may fail, like some customer is calling us, some other clients are calling us, and if they fail or if they keep retrying the same APIs with the same data, we need to handle that properly. That means we need to make sure our API has considered the idempotency when we have designed it. Otherwise, our service data will get corrupted and it will fail eventually. Number 13, minimize critical dependencies. We know like fewer dependencies lead to fewer failures, so we should try to minimize the critical dependencies. Number 14, implement rollback mechanism. This is one of the very important thing of our deployment process or like release process. We need to ensure that our release process or pipeline has the mechanism to automatically roll back any failures or any deployment. So these are kind of like 14 different things we talked here, which can help us to improve the availability of our services. But there are many more in the open source or like industry wise practice. We can also read online more. Thank you.